What's going on, guys? Welcome back to this video. Today's video will be on TryHackMe, and we're resuming the threat modeling room. So in the last video we covered the MITRE, ADT and CK framework. We explained the details. Today we're going to explain the threat framework, and as I told you guys before, I am taking every framework into a separate video so that to maximize the learning benefits. So today we'll be learning about a threat framework. Remember that the threat framework and the MITRE, ADT and CK and other frameworks such as Stride and PAST are all part of threat intelligence and modeling. So when you if you are part of cyber threat intelligence team and you're conducting a threat intelligence and modeling campaign, you want to use one of these frameworks. Now, today's framework isn't as popular as the MITRE. It is the threat framework, and it is actually a framework that is invented by Microsoft. So the framework is subjective in nature. Okay, let's scroll down here and see where it is, this framework. Yeah, it is the threat framework. So it is kind of subjective framework in nature. So you have categories. It consists of five categories: the damage, reproducibility, exploitability, affected users, and discoverability. So as you can see, guys, previously we learned that the MITRE, ADT and CK is a very broad framework to assess security threats based on the adversary profile. So we study the adversary, the attacker or the adversary profile by going over the tactics. Okay, what are the tactics they take to achieve the techniques, initial access, compromise. We learned all of that and the common knowledge, and also we derive the mitigations and detections from this framework. So it's much broader than the threat framework. Now, threat framework is subjective in nature. It's used to assess the risks. So what kind of scenarios we use the threat framework? So threat framework comes into use, guys, when you are implementing a new program, a new information security program, when you are conducting threat intelligence, when there is a new change in the organization, when there is a new technology introduced in the organization, you want to assess the risk. Even if you are conducting a risk assessment, okay, you can use the threat framework. So as you know, guys, risk assessment or risk management is part of any information security program, and to conduct the risk assessment you have to use frameworks as reference for your work. So here threat framework can be used, for example, beside NIST cybersecurity framework. So the threat framework is used to assess risk in a qualitative way. Qualitative risk assessment is the opposite of quantitative risk assessment. In qualitative risk assessment, we assess risks and categorize them based on the impact: high impact, low impact, medium impact. While in quantitative risk assessment, we assess the risks based on numbers. So threat framework is a qualitative risk assessment. So it heavily relies on your subjective opinion about a specific vulnerability and how you're gonna assess it. Is it high impact, is it low impact, or is it medium impact? So the threat framework can be explained by going over the acronyms. So the first letter, D, stands for damage. Damage is actually assessed by how bad an attack would be. So the damage is actually represents the potential harm that could result from the successful exploitation of vulnerability. Okay, so what kind of harm? What's the impacts, right? It could be like data loss, system downtime, or reputational damage. Then we have the R. The R stands for reproducibility and represents how easy it is to reproduce the attack. So if the vulnerability is simple and the exploit is available publicly, it means the attack can be reproduced very easily, which renders the impact to be high because anyone can do it. The ease with which an attacker can successfully recreate the exploitation of a vulnerability. Now, the E stands for the exploitability and represents how much work is it to launch the attack. Does it require a savvy knowledge, or does it require minimum knowledge? Meaning, can script kiddies easily exploit the vulnerability, or does it require more resources as in tools and skills? The difficulty level involved in exploiting the vulnerability, considering the factors such as technical skills required, so on and so forth. The affected users, it's in the A. Like, who are the affected users and how many of them are impacted by the attack? Is it only the user that who is using the endpoint, or is it the entire department, or is it the entire users of a specific app? Affected users, that's how it works. The discoverability, it is the last D. So here we compose the Dredge framework. Discoverability represents how easy it is to discover the vulnerability. Like, is it easy to discover? Is it available? It can be uncovered by a simple Nmap scan or Nmap scripting engine, or just require minimum digging, or just require, more digging. So the ease with which an attacker can find and identify the vulnerability, considering whether it is publicly known or how difficult it is to discover. Like, it could be 0 day. The 0 day is quite more difficult to discover than publicly exposed vulnerabilities. So here is the definition of every single aspect of the Dredge framework. So we use the damage, reproducibility, exploitability, affectors, and discoverability as scales to determine how dangerous the vulnerability is. So how it works, so for every category, the damage, okay, reproducibility, the exploitability, for every category we assign a score. Okay, that score ranges from 0 to 10, right? From 0 to 10 for every category. Okay, we assign a score from 0 to 10. That depends on the current security posture of the organization and depends on the vulnerability itself. There is an example that is given in this room here. Take a look at this one. Unauthenticated remote code execution. That is a vulnerability. Say that a penetration test has revealed one of your publicly exposed applications, such as maybe a web server, is vulnerable to unauthenticated remote code execution. The pen tester gave you the report, and that pen testing was part of an overall risk management plan. So right now, if you want to assess how risky it is, or how risky it is, the vulnerability, you're going to use a framework. You want to assign a score. So to assign a score to such vulnerability and therefore prioritize the patching or the mitigation of this vulnerability, you're going to have to assess the risk. So we're going to have to go over these categories. So let's assign, or let's see what kind of damage it may cause. So we said that it ranges from 0 to 10. Now in the room, the guidelines here are given by the author, but the guidelines I put here, guys, are more generic, which can be used in every single scenario. Let's go back here to this one, unauthenticated remote code execution. So how are we going to assign the score? So as you can see, 0 indicates no damage, caused to the organization. 5, information disclosure said to have occurred, but we don't know yet to which impact. 8, non-sensitive user data has been compromised. So how do we know? How do we know which one to assign to damage? That's why that's how we call the Dredge framework subjective, because we're going to assign the number based on our knowledge and our opinion about the vulnerability. So based on your knowledge and your opinion. What do you think unauthenticated remote code execution may cause to a web server? What do you think the damage could be? So you're gonna go back here and you're gonna assess. Unauthenticated remote code execution could lead to a system compromise, full system compromise, which means the entire information system has been destructed. All data and applications are inaccessible. Nonsense data, it could be 9, it could be 10, or could be 8. So here they assigned it the 9, because an attacker who has access to the system through RCE, they could do whatever they want. They could destruct the system, they could steal administrative and non-administrative data. So 10 is the correct score for the damage. Let's go now to reproducibility. How easy it is to reproduce the unauthenticated remote code execution. now that depends on the vulnerability that caused the RCE. Okay, is it easy to exploit? That's how you're gonna assess, or that's how you're gonna assign the number. So 0, difficult to replicate the attack, complex to replicate the attack, 5, easy to replicate, and 10 for very, very easy. So here they gave it 7.5, which is this one. It's easy to replicate, right? But it's not very, very easy to replicate. Why? Because an RCE can be replicated fairly easily if you know how to find the entry point. Like, could it be a simple CVE that you exploit and gain access? That's why it was actually rated as easy. It's not very, very easy because it's not a simple web application weakness such as directory traversal or file inclusion. These seem to be very easy to replicate. You just have to manipulate the URL parameters and you will be able to show that, yeah, this app is vulnerable to file inclusion or directory traversal. But RCE, it could either be complex or easy to replicate. Now, exploitability. So here, how easy it is to exploit the vulnerability. Now, it depends whether it is 0-day or publicly available. So here 10 indicates the requirement of a web app browser need to exploit the vulnerability. 9, web application proxies are needed to exploit the vulnerability. What are the tools, what are the skills required to exploit the vulnerability? Hence, we can determine the exploitability of the number that we can assign to the exploitability. So here they assigned 10 because in RCE, it's rather easy to, all you need is a web browser and a reverse shell. Now the affected users, if you have RCE, all users can be affected. So also it's given 10. And lastly, discoverability. How easy it is to discover the RCE. Well, 0 indicates it's hard to discover the vulnerability. No, it's not hard. And we have 5, 8, 10. So here they gave it 2.5. 2.5. It falls between 0 and 5. So 0 indicates it's hard, and 5, HTTP requests can uncover the vulnerability. Vulnerability found in public domain. Now, the thing is, guys, it depends on the scenario. So here they gave it 2.5. Because the scenario here, I think it is this. A software company has developed a new website and needs to assess the risk associated with various security threats. It is a simple website. Your team has created a guideline for scoring each component. So 2.5 was based on this representation or explanation. The significant effort needed to discover the vulnerability chains for the exploit to work. So I don't think there is 0 here. Let's put 2.5. Yeah, that would fix the problem. There is another scenario. Insecure direct object reference. Now, yeah, I forgot this. So as you can see, the score is 8, which means it is highly dangerous vulnerability, risky, right? It has a priority to be mitigated. So how do you calculate the score? We actually take the average. We sum all of these numbers and we divide them on 5. That's how we get 8. So 8 represents a vulnerability that is high in risk, or that poses a high risk. So in your risk management, when you finish your risk assessment for the discovered vulnerabilities, you're gonna have the scores and say, look, we have these scores for each of these vulnerabilities, which means this one is high, this one is medium, and this one is kind of medium. So we're gonna prioritize in our patch management program or risk mitigation. We're gonna prioritize the mitigation of risk of this risk, right? And then we're gonna go further with those that are lower in score. This one is 6.5. Let's go over insecure direct object reference. So the damage, it is 2.5. That's true. If we go up, so here the guidelines are different. So minimal infrastructure information disclosure. So here in the damage, we're gonna have to, as you can see, these are different. The numbers are different. It doesn't have to be the same, but in insecure direct object reference, we cannot say that no damage has been caused to the organization, right? So it cannot be 0. Information disclosure is said to have occurred. So we can either assign 5 or 2.5 because insecure direct object reference can only lead to minimal disclosure of information, right? So it could be 5 or it could be 2.5. So here they said it's 2.5. It depends on the scenario. This is the scenario they give. If they give you a scenario, you stick to the scenario. If they don't give you a scenario, just use generic guidelines. Now let's go to reproducibility. So it is 7.5 because it is rather easy to reproduce the IDOR vulnerability. Little prerequisite technical skills needed to run the exploit, because in IDOR, as you know guys, we just have to manipulate the URL parameter and change the values to be able to reveal information that was not meant to be revealed. Exploitability is also very easy to exploit. The vulnerability requires minimum knowledge, minimal skills are required. Now it doesn't have Metasploit module, that's why we didn't assign 10 to exploitability. Affected users, it is 10 all users, and discoverability, it is kind of requires a manual way of verifying the vulnerability. That's true. There is no script that can be deployed to discover the IDOR. You have to do it manually. And this one as well, server misconfiguration leading to information disclosure. The same way you could assign the numbers. Reminding you guys that if you are given a scenario such as this one, stick to the scenario when you are assigning the numbers to each category. If you are just given a pen testing report or a vulnerability report and you are required to assign the risk, right, for every vulnerability according to the Red framework, rely on generic guidelines to assess to assign the numbers for each category. Let's answer some questions and we wrap this up. What Red framework or component assesses the potential harm from successful exploiting a vulnerability? It is the damage. It deals with the impact. What Red component evaluates how others can easily identify the vulnerability? It is the discoverability. And lastly, which Red component considers the number of impacted users when a vulnerability is exploited? It is the affected users. So you can visit this link, guys, to read more about the Red framework. It is in the Microsoft website. I'm gonna put this in the link description. Take a look at this. Sample assessing threats using DRED. Look at this table. Damage, as you can see, was given 8. Heat was given 10. And total was 9. Mitigating this problem is high priority. So it was on this one was kind of with no example, but they gave you example how to calculate the number, define a number. Now define a number, guys, is very important because it indicates how risky it is to leave the vulnerability unpatched. Okay, so if you decide if the number is above 8, 9 or 10, it is really risky to leave the vulnerability unpatched, and you have to somehow either patch the vulnerability or just minimize attack exposure. So you can use the number here to strategize, or let's say create your mitigation strategy or risk mitigation strategy. Now remember, this is all part of risk management. And here also they explain the STRIDE framework, which we will go over in the next video. So when we finish the series here on the threat intelligence frameworks, we'll be able to conduct any threat intelligence and modeling campaign, and also participate or use the results in any risk management plan. Reminding you guys that this is part of the it was part of the security engineer path. Okay, so guys, that was it. I hope you enjoyed the video, and I will definitely see you later.